This is Hui. Welcome to watch my video, C++ programming on Linux. In this short video, we're continuing discuss Libevent, an event notification library. In previous video, it has demonstrated how to write a C++ TCP client program using Libevent. In this short video, we are going to write a C++ TCP echo server program using Libevent. For network programming, both the server side and the client side have to create a socket and communicate over the socket, but the process flow and the pattern has a little different. In general, client side open a socket for single communication and the server side open a socket for connect to multi-client, so it will return listener waiting client connection request. After accepted client request, it will return file descriptor fd to establish the connection between the client and the servers. Here is the diagram. Client open a socket and send a connect request to server for exchange data. Server open a socket for listening client connection request. After received client connection request, it will validate and accept client connection between server and the client. Here on Linux, we create a C++ program, my event server.cpp. It is a TCP echo server application. To use Libevent, the header file is event.h. Before we start coding, we declare some global variable. Max line is the buffer size for sending and receiving message. Structure my event parameter is used for passing parameter among event and callback functions. In this structure, we declare buffer of maximum line. Buffer used is the message size. Pointer of base is the event base. Pointer of read event is event for receiving messaging from the socket. Pointer write event is for sending message to the socket. Corresponding to this event, doRead function is the callback function of read event. DoWrite function is the callback function of write event. DoAccept function is the callback function of listener event. The usage of this program will take one argument, port number. We receive port number from argument 1, convert to integer, and pass to the run functions. Function run will have following steps. Step 1, assign socket address using structure sock_addr_in. Step 2, create a new socket using function socket. Step 3, binding a name to socket using function bind. Step 4, listen for connection using function listen. Step 5, create a new event base, function event base new. Step 6, make a socket no blocking using event utility, make socket no blocking. And step 7, create a new listener event and add to base, function event new and event add. Step 8, dispatching the event to the event base loop. Step 1, assign socket address, name sign, domain sign family. AF is for IPv4 Internet Protocol. Address in ADDR_ANA, it means we accept any incoming messages. Port number. Step 2, create a new socket as a listener. This function takes 3 parameters. First parameter is the domain. IPv4 Internet Protocol. Second parameter is the type. Sock stream, it's a two-way byte stream and flag 0. Step 3, bind your name to socket. Function bind your name to a socket. This function takes 3 parameters. First parameter is the FD. Second parameter is the socket address pointer. And the third parameter is the socket address length. Return value. On success, 0 is returned. On error, -1 is returned. First parameter is the listener. Second parameter will be the socket address pointer, SIN. And the third parameter is the length of the socket address. If the return code less than 0, it means the error. So we print an error message. And return. Step 4 is the listening the connection. Function is listen. Function listen for connection on a socket. This function takes 2 parameters. First parameter is the socket FD. Second parameter is the backlog. The backlog argument defines the maximum length to which the queue of pending connection for socket FD may grow. So it's a maximum queue for the connections. Return value on success, 0 is returned. On error, -1 is returned. Return code equal listener. Second parameter is the maximum of the queue, so we just pick any number 16, hard coding. If return code less than 0, it means error, so we print out the message and return. So we have successfully created a socket, bind your name to a socket, and listening for connections. Step 5, create a new event base using the event base new. Base equal. If not created the base, means we have an error. So print out the information and return. Next step, make a socket no blocking. Next step, to create a new listener event. First parameter is the base. Second parameter is the listener. This listener event will read socket, so type will be evRead. Callback function do accept. Parameter to pass this callback function is the base. Add this event, dispatch the event loop. Now we finish our run function. We're going to write the callback function do accept. Function do accept is a callback function of listener event. This function will do following steps. Step 1, decoding the argument. As we know, the argument passed to this function is the event base. Step 2, declare socket address using the sock_addr storage. Step 3, accept connection on socket and return on FD function accept. If success, will be set socket no blocking allocate the memory for my event parameter, initialize my event parameter, create a read event callback function, do read. Step 8, add read event to event base. Base, casting. Step 2, declare socket address. Name SS. The reason we use socket address storage because this structure at least as large as any other socket address, so it's safe to casting. Socket length, SLAN. Step 3, accept connection. Function accept connection on a socket. This function takes 3 parameters. First parameter is the socket FD. Second parameter is the pointer of address. Third parameter is the address length. Return value on success. This system call returns a file descriptor FD. On error will return -1. So first parameter listener. Second parameter address. Third parameter address length. If FD less than 0, it's error. If FD greater than FD set size, it means over the limit. Else success. For FD less than 0, for FD over the limit, we just close FD. On success, first set socket no blocking. Allocate memory for my event parameter. EVPTR. malloc is very popular for allocate memory and memory set. Then we initialize my event parameter. Buffer used equal 0. Event base equal base. Read event none. Write event is none. Next step, create a read event and add this read event to the event base. First parameter is the base. Second parameter FD. Type read. Persist callback function. Do read. Parameter pass to the callback function evptr. Add this event to the event base. Now we finish our do accept function. Next, we are going to write read event callback function do read. Function do read is the callback function of read event. This function will do step 1 decoding the argument, step 2 memory set message buffer, step 3 receive a message using recv. If a message received, create a write event using the event new callback function do write and write message back to the socket. Step 5 add write event to the base. If no message received, free the memory allocated. Step 1 decoding the argument. evptr casting. Declare a pointer, point to the beginning of the buffer. Step 2, memory set message buffer. Next, receive the message from socket. Function receive. Receive a message from a socket. This function takes 4 parameters. First parameter is the FD. Second parameter is the buffer, where we message save to. Third parameter will be maximum length. Fourth parameter will be the flag. The return value, this call return the number of bytes received, O minus 1 if error occurred. Received length equal first parameter FD, second parameter will be the pointer of memory buffer PTR, third parameter maximum length of buffer, the flag is 0. If received length less equals 0, it means we received nothing or error, so we just free our event, allocate memory, and free the buffer we allocated. Free. If success, buffer used will be the received length. We print out the number of bytes received and our message received. Next step, create a write event and add to the base. First parameter is the base. Second parameter is FD type. Callback function. Parameter is my event parameter, evptr. Add write event to event base. Now we finish our do read function, and we're going to check do write event. Function do write is the callback function of write event. In this function, it's going to do following steps. Step 1, send the message back to the socket, and after finished, remove the write event from the base. So first, decoding the parameter, cast, declare a pointer, point to the message buffer, declare remaining byte, equal buffer used, byte sent equals 0, we print out byte of a message we send to the socket and the message. Create a loop while remaining greater than 0. We use a function send. First parameter is FD. Second parameter is the pointer of a message buffer PTR. Next is the remaining. Flag is 0. Byte sent less or equal 0. It means we send all the message, so we break the loop. Remaining minus the byte sent and pointer forward byte sent. Finish the loop, we remove the write event from the base. The function will be. Then we finish our do write function. Now we save our program. We compile our program. our program has been compiled. This is executable my event server. To test our example, we using two terminals. Top terminal is on the Ubuntu Linux IP address 10.0.0.191, which we have just wrote and compiled our event echo server executable my event server. Bottom terminal is on the Debian Linux IP address 10.0.0.124. We're using one of previous videos TCP echo client example to test my event server we just wrote and compiled. First, we start our server, my event server, port number 1234. Now server has started. Bottom terminal, we start our client, IP address 1.0.0.191, port number 1234. Now we are ready to write a message to server. This is Hui test message 1 from Debian Linux. Our server do read event, receive this message, and the server reply back. This is Hui test message 1 from Debian Linux, and our client receive this message. Now we write again. This is Hui next message 2 from Debian Linux, and our server receive this message. Do write event, reply this message back, and our client received this message. Lab event has been widely used in many network and I/O applications. The advantage of using lab event, it will increase the efficiency and the performance of application running. So it is very popular and widely used in many applications. Hello, this is Hui. Thanks for watching my video. Wish it is useful, and it's going to be great to have your feedback.